All right. Welcome to the Pre-Cal Honors Group. I had two questions pop up here on homework from day one and then day two, and I owed you a short video on how to solve these two problems. And these both involve an inclined plane, so I don't want you to panic. These aren't difficult. You just have to think about them a little bit differently. All right, number 47 says, moving a heavy object. Suppose the box described in exercise 46 is being towed up an inclined plane as shown in the figure below. And I blew this picture up so that we could see it and write all over it. Find the force W needed in order for the component of the force parallel to the inclined plane to be 2.5 pounds. Well, what we need to know is that this is the magnitude of a force, okay? And we want the force, the component that's parallel to the inclined plane. Okay, so what I want you guys to consider here is, here I am, I'm going to draw W, and I'm going to just look at this section here, okay? And W is going to have a horizontal here. And this angle here, this whole angle is 33 degrees. But it's going to have a component that's parallel to the inclined plane here. Okay, so here it is. I'm going to draw this part. This is the component that's parallel to the inclined plane. All right, and if this whole angle is 33 degrees, and this is 15, guess what else is 15 degrees? Well, this is 15 degrees. Because if I draw the component up here, you'll see that better. I know it's pretty small, but this is 15, and so is this. Okay, so if this is 15 and this is 15, which makes this 15, and this is 33, what does this angle have to be? Well, it has to be 33 minus 15, right? Because this is 15, which makes this one 18 degrees. That's this angle here, which is this angle right here. Okay, and then I want you to consider this as a right angle here, if I bring this down. Okay, and I want the force parallel to the inclined plane to be 2.5 pounds. So I want this part right here, I'm going to put it in like this peachy color here. I want this force to be 2.5. Okay, so I have a right triangle there. So I'm going to draw it. Here it is. Here's my W. Here's my other one. And I want this to be 2.5. And this is W. I'm going to put the magnitude of W here, right? And this is the magnitude here. And I know this is 18. And this is a right angle. So if I know that this is a right angle, well, guess what? This W happens to be the hypotenuse, and this is the adjacent. So I can say using cosine theta, well, what is theta? Theta is 18. So I can say cosine of 18 degrees is going to equal 2.5, which is the adjacent, over the magnitude of W, which is what I'm after, right? And I can cross multiply, get the magnitude of W times the cosine of 18 degrees equals 2.5. The magnitude of W is equal to 2.5 over the cosine of 18 degrees. And I need to get my handy dandy calculator. Sorry, I should have had it closer to me. And let's see, I am in degree mode, which is nice. So I'm going to say that I'm going to do a second quit here. And I'm going to go 2.5 divided by the cosine of 18 degrees. And I'm going to get 2.62. So magnitude of W is 2.6286, blah, blah, blah. Okay. I'm actually going to stow that number. Stow alpha A. There we go. All right. Give the answer in component form. Okay, well, I found the magnitude. And the component form of W is going to be, there's W, and now I need to know what this component is and this component is, which is, this is going to be, this component, I'm going to do it in green, blue. It's going to be this component and then this component, which is different than this one. Okay, so I know that this is a right angle. I know the magnitude of this is magnitude is 2.6286. And I know this angle is 33 because they told me. And I can find this in component form. So W in component form is going to equal the magnitude, which is 2.628 times the cosine of 33 degrees, comma 2.628, times the sine of 33 degrees. All right, and in my last video, I showed you guys how to do vectors, but if you don't remember, you can use the curly braces. So we can go second curly brace, and I can say alpha A, right, because that's where I stored my magnitude in, times the cosine, 33 degrees, comma, alpha A times the sine of 33 degrees. Second curly brace, and there's my vector. So it's going to be my component form of my vector for the W is going to be 2.20, comma 1.43. That's the component form of the force W that I need for it to be parallel in 2.5 pounds. Okay? All right, so that's 6.1. The tricky part of that is knowing that they want the component part first that's parallel. So you got to use this small angle in the right triangle. And then after that, then they just want you to go back to the straight up horizontal and using 33 degrees. All right. 6-2. Number 47. It's like number 47 caused heartache for a lot of people. So, all right. Braking force. A 2,000-pound car is parked on a street that makes a 12-degree angle with the horizontal. See the figure. Find the magnitude of the force required to keep the car from rolling down the hill. Okay, well that means that the force of the car that's being pulled up has to overcome the force of 2,000 pounds of the car. Okay, so you're going to have I'm going to put an inclined plane here. Here we go. Here's my inclined plane, and here's my car. This is my, horrible rendition of a car. And this is 12 degrees. But I'm going to have a force directly down that's going to be 2,000 pounds, right? Because that's the weight of the car. mg for the car is 2,000. Okay? Now, I'm going to have a force that's going to keep the car from rolling down the hill, which means I'm going to have a force either coming out this way, because remember, vectors can be moved all over the place, that is going this direction, that's holding the car in position or pulling the car in position, but it's going to be a force like that. So I'm going to create a triangle using these two vectors, okay? So here it is. Here's my first vector, and then here's my 2,000, which is straight down. And then I'm going to drop a perpendicular. It's not really dropping, but this is the force that I want to know. And this is 2,000. Now that's a magnitude, so this is a magnitude. And this is a right angle. Okay, so the only thing I've done is I've moved this vector right here to right here. And I've moved the mass vector, or the weight vector, to over here. That's all I've done. They are the same magnitude in the same direction. I just, put them together. And then created a right triangle here. Okay. And why did I create a right triangle? Well, because I know that this is 12 degrees. If this is 12 degrees, then I know this angle here. This angle here has to be 78 degrees. Okay, which means this angle is 78 degrees. Which means this angle is 12. And I want to find the magnitude of the force. Well, I don't know that, but I do know this, and I know an angle. So this is the hypotenuse. The 2000 is the hypotenuse. So I can either use 12 or 78. So since I used cosine on the last problem, let's use sine. So if I use sine, this would be the opposite. I could use either, but I'm just trying to be different. Let's using sine theta. So if I use sine theta, then I'm going to have to use this angle here because the force is the opposite. So it would be the sine of 12 degrees is equal to the opposite, which is the magnitude of the force that I'm after, over 2,000 pounds, because that's the hypotenuse. And so the magnitude of the force is equal to 2,000 times the sine of 12 degrees. Okay, magnitude of force. Out comes the big gun, the big calculator here. So we're going to go 2,000 times the sine of 12 degrees, and we get 415.82 pounds. Now this has to be in pounds because the car is in pounds. That force was given in pounds. All right, so that's looks like that's part A. Part B says, find the force perpendicular to the street. So now I got to find this one. Oh, wait. Yeah, because this is the street. The street's at a heck of an incline, isn't it? That's like driving straight uphill. I mean, like really driving uphill. Okay, so I need to know what the magnitude of this one is. So I'm just going to call this force 2, so if that's all right with you guys. You don't have a choice. You can't talk to me. I'm really sorry about that. All right, so should we use cosine just because we used sine a minute ago? Using cosine theta. If I want to know this, so the adjacent is 12. So we'd say cosine of 12 degrees has to equal the adjacent, which is the force number 2 that I want to find, over the hypotenuse, which is 2,000. Right? So cross multiplying, I get the magnitude of the force perpendicular to the street, because this is the street. If you can't see me writing the street, that's equal to 2,000 times the cosine of 12 degrees. I'm going to pull out my handy dandy calculator and say 2,000 times the cosine of 12 degrees. And we get a force of 1,956.30 pounds. A whole lot more perpendicular to the street. There we go. And that would be the answer to number 47. So what do you have to do with 47 that's a little bit tricky? Well, you got to know that you can move the vectors, which really bugs people sometimes. But you're going to have a force that's either, pushing or pulling on this, right? And you can move this vector physically here and move this one physically here because they have them the same direction and the same magnitude, just in different. I just moved them in space. And then I can create a right triangle, creating a perpendicular to the street situation, and then use sine and cosine to solve those. Okay? All right. You guys have a good one, and we will talk to you next time.